Okay, I'm going to try to make this example video here to explain the difference between number 9 and 17 on lesson 5 practice. So for number 9, first of all, it's a semicircle, which means half of a circle. Okay, and on number 17, it's a quarter circle. So automatically we know that for a semicircle, the area is normally pi r squared, and this is half a circle, so we have to divide by 2. And for a quarter circle, the area would be pi r squared divided by 4 because it's a quarter of a circle. So it's like 1/4, okay? So these are just the normal standard formulas for a semicircle and a quarter circle to find the area. So then what we need to look at is that in this case, we're talking about an area that is bounded by the x-axis, the y-axis, and a given equation. In this case, the given equation is y equals 2 minus 1/2 x squared. And when we do all of the algebra to get this solved for x, we get the square root of 4 minus 2y is the value of x. That means if you're going from the y-axis to the line, y equals 2 minus 1/2 x squared, the value would be the square root of 4 minus 2y. On the other one, number 17, the equation that you're given is x equals 6 minus 2y. Unfortunately, we don't have to solve for x because it's already there. But this means that the measurement of x, meaning from the y-axis to the line that we've been given, the distance is going to be 6 minus 2y. Both of those things are going to be important because what we're talking about here is that we're cutting out a piece. When we're saying what's the volume of the solid whose base is bounded by these lines, it's like if we were to cut through there in this shape. So if we're cutting through in a half circle, a semicircle, it's like this. Imagine that that's a good circle. But the boundary, this side of it, is x. This is the distance, x right here, which we already said is the square root of 4 minus 2y. Well, since we need the radius, because here in our area formula we need the radius. Well, the radius of the circle is from the center out. So in a half circle, the radius is half of that. So in this case, r is going to be 1/2 x because it's half the distance of the base, which we said that the shape that's on the base is a semicircle. In the case of number 17, it's a quarter circle. So instead of getting a half a circle, when we cut it, we have this quarter circle. So it's like this, and x is right here. Well, if this is a quarter circle, then that means the radius is already given to us. And we already know that the x is 6 minus 2y, because that's what we were told up here in our equation. And so the radius is x. It's 6 minus 2y because we don't need to cut it in half because we have half a circle. We actually only have a quarter circle. The quarter circle already is based on the radius because from the center of the circle out to the line of the circle is the radius. So in this case, when I take this information and I go back to my original area formula, in this one, I'm going to have a equals pi r squared, so pi divided by 2 times r squared. In this case, that's going to be pi over 2 times, let's just call it x over 2 instead of 1/2 x. And when we simplify this, I've got pi over 2 times, let me rewrite that, x squared over 4, which can be finally simplified. I can go ahead and multiply my denominators, and I have pi over 8 x squared. And so this is my area formula for this piece of the semicircle. Then on this other problem, number 17, it's a quarter circle, so we already gave our original formula here, pi r squared over 4. In this case, r happens to be equal to x, as we said, because we already have the radius. And so that means that when I do the formula, a equals pi over 4 times r squared, I didn't need to put the parentheses, but you get it, r is x, right? We said that. So in this case, it's pi over 4 times 6 minus 2y squared, right? And actually, I got ahead of myself. We're just right now simplifying with x like we did over here. Oops, I didn't mean to be erasing. So here we just simplified to x. I'm going to keep the x. So it's pi over 4 times x squared, and that doesn't simplify any further. So this is actually just the formula, pi over 4 x squared. And that's why it seems maybe counterintuitive that a semicircle would be pi over 8, but a quarter circle is only pi over 4. But it just narrows down to the fact that in the semicircle, you already have the radius equaling x. And in the semicircle, the entire half of the circle, like all the way across, the diameter equals x. And so to get the radius, we have to divide by 2. So I believe that answered your question. Let me know if not.